Okay, so we're going back to 8.1, solving systems of equations. So if you have a TI-83 or any graphing technology, like I said, you can use the calculator online. Go use that if you want to look at it. Yeah, you can if you want. Go over there. Go use the computer. Do it right now if you want. Log in. If anybody wants to use the computer while we're doing this lesson, by all means, but you have to be actually on the graphing calculator. Okay, so here's the deal. There's two equations. You know how to solve this algebraically, right? You can either do rearrange it, substitute it in, or you could use elimination method. If we want to use it with the TI-83 with the graphing calculator, first thing I want to show you is, look at the TI-83. If you turn this on, nice how it really works today. Eh? Here, let me. Could you, hey, just please. Let's turn this on here. Okay. Now, if you look up here, do you notice it says the top left-hand button? All those blue buttons across the top are graphing functions. All those buttons across the top are graphing functions. The one on the left is y equals. So I have two formulas up there. What do you think you have to do to both those formulas? You got to turn them so they're all both equal to y equals. And the y has to be positive or negative? What do you think? Positive. Okay, so let's rearrange these two equations. There we go. So the first one, negative y equals, move the 4x, negative 4x, move the 3, negative 3. Then what do you do with the negative? What do you do with all the signs, basically? Yeah, you divide, so it changes all the signs. Okay, so there's one of them. Y equals 4x plus 3. Now what is that, by the way? Linear or quadratic? Linear, it's a straight line, right? Do the next one. Okay, we're going to move the negative y, we're going to move the other stuff to the other side. Negative 2x squared minus 8x minus 3, right? Then what do you do with the negative? Basically, it switches all the signs, right? You could, but I'm putting the y on the left because I want to make sure you understand when you put it into the calculator, it's y equals. Some of you might mix that up if it was the number then, or all the rest of the polynomial then equals y. I just want to make sure it's on the board like you're going to put it into the calculator. Sorry, what is this? Plus 3. Okay. So there's our two equations. What's that? Linear or quadratic, by the way? Quadratic. You can tell right away because of the square, right? Okay, let's go back to our calculator. Pop that up on the screen. So the first one I'm going to put in is 4x. Now, if you haven't used your calculator before, right beside the alpha button, the green button, is the variable button. And you press that and it'll actually put in the x for you, if you haven't done this. Then plus 3, so plus 3, there's the first one. Move down. Now if you notice, do you see the equal sign in front of the 4x? It's highlighted now, which means it's turned on, right? So it's actually going to plot this one. If it's not highlighted or turned on, it will not plot it. What's the next one? 2x squared plus 8x plus 3. Okay. Simple as that. Now, the hardest part about this, and I think if anybody's either taken applied or used the graphing calculator before, is setting the window. Right? The window is the pain of this whole calculator. Because you never know when you set your x and your y to, right? Your x is positive that way to the right, your x is negative to the left. If you're ever unsure, always set it to what's called a standard window, which is negative 10 to positive 10, negative 10 to positive 10, right? X and Y. Does anybody know where that is? Where do you find it? Actually, window is if you want to change the settings, right? But if you actually go to zoom, why is it working now? Okay, if you actually go to zoom, you'll actually see on number 6, what is it? Standard. So you can actually just press 6, or you can scroll down, and it'll do it. So there's a standard window. That sets it negative 10 to positive 10, negative 10 to positive 10. It is. In this case, we're good. Now, the problem with this one is the area that we want is in the probably quadrant 3 and somewhere up there. I can't see it with this graph because it's a little packed. So can we change the windows on this to make it a little bit bigger for us? So let's change the windows. I'm going to show you how to change the windows so you know how to do this. X min, X max, Y min, Y max. X scale and Y scale is how much it goes up by. It goes up by 1. So let's change X min to negative 5, positive 5, negative 5, positive 5. And then how do you get it to regraph again? You press the button graph. It actually makes sense. How's this one? Is this a little better? Oh yeah, look at that. That's way better. Well, the problem is now what can't I see? I can't see the intersection on the bottom of the y. So instead of negative 5, what should I make that? Negative 6 or negative 7. Okay, that's not bad. But you see, you have to take a little bit of playing around with the buttons to get it to work right. How's that? Oh, that's good. That works. Okay. Now what are we looking for? What's the whole purpose of solving equations? You find the intersection points, right? You're trying to find x's and y's. And in this case, how many solutions are there? There's 2. There's one down here in quadrant 3, and there's probably one up here. It's either in quadrant 1 or 2, or it might even be up right on the line, eh? Okay, how do we find the intersection point? Second trace. Now, if you notice, right above trace is the calculation button. So we go second trace, and that actually throws up all our stuff. You should have seen some of this stuff before. Zeros. Say, what's zeros again? X-intercepts or solutions. Oh, min and max. That should seem familiar. If you had a quadratic, could you find the minimum value? The vertex, basically. And could you find the max value? The vertex again. Oh, wow. These calculators are really useful as tools, right? It's technology that's there to help you. You still have to have a good basis of understanding. You still have to know what we're talking about. Which one are we looking for? 5, the intersection point. And there's 2 of them here, so. Okay, so. What? You can press 5. I did it by number the first way, or you can scroll down. I'm just showing you both ways. So what we want is you're going to have to do this twice, right? You're going to have to find the first and second curve once, which is this down here, and the first and second curve twice. So let's see. So now you can move around here. I'll move my arrows. Yeah, that one works. Basically, if you're ever unsure, hit enter and enter, and it should automatically. The calculator is pretty smart. It'll often pick up the first and second curve. Now, it says curve, but basically they're talking about line or equation, right? It's not always curve in this case. So let's hit enter and enter. Oops. Why is this, hang on. It's right there. We'll hit enter and enter. Now, it's always going to give you, it always comes up as a guess. The reason they put that in the calculator is they actually want you to think about what your answer is going to be before you actually press the button. Right? Now, looking at that graph, what do you think a reasonable answer to that top intersection point is? 0 and 3, 0 and 4, 0 and 2.5, somewhere in there, right? So hit enter and see what we get. Enter. We get a point of intersection of, that's the weirdest thing I have ever seen in my life, 1.365 e to the negative 14. Guys, that's scientific notation. It means 1.3 times 10 to the negative 14. So think about that for a minute, what that actually looks like. How many zeros? 1, 2, 3. How many zeros? 13 zeros and then 1, 3. Basically, what is that number? 0, right? It's a calculator, right? Sometimes the calculator, when it's doing calculations, can't refine it down to a simple number. When you see something like that, like 1.3 to the negative 14, basically what is it? It's a tiny number, or it's a 0 in this case. And what's the y value? 3. Okay, that's what that answer makes sense. Okay, so one of the points is, right, so one of the solutions is 0, 3. That's one of the solutions. Okay, let's try the other one. So let's go back to second calc. We're going to go to intersection point, which is what, number 5. So first curve. Now I'm going to move way down here, so I know I'm way down at this other curve. So I'm moving my arrows down to below there. There's the first curve. Enter. There's the second curve. Enter. It's going to give me a guess. What do you think this one's going to be before we even do it? Looks like negative 2, comma, negative 2, negative 5, you think? Yeah. Let's find out. Negative 2, negative 5. Wow. So that's the second point. So negative 2, comma, negative 5. Easy with technology, though, isn't it? Super easy. But do you still have to do it mathematically? Do you still have to do it algebraically? Yeah. So if you're doing this on a question, if you're doing this on a question, right, you can actually you can do the math and then quickly check it with your calculator. Put that on there and then we'll do a little more. Yeah. Let's try the next one. Super easy. Excellent. Now, look at this guy here. What do you notice about this right away? What is it? Two quadratics, right? We don't have to. So try it afterwards and try it algebraically. The lesson I'm showing you today is all graphing, right? And it's a simple one. So those that don't have calculators, it really doesn't apply to, right? The questions that you do in 8.1, you still have to do algebraically, right? You have to do them. You can, well, how do you check your answers? You do it by verification, right? Plug in an x and the y and see if you left side equals right side. But you still have to do it first and foremost algebraically. Can you use your calculator to check your answers? Yeah. Okay, let's do this one. So can I plug both of these into the calculator right away, or what's wrong with them? You got to move them around. Okay. So let's do the first one. Negative y equals negative 2x squared plus 16x minus 35. Is that correct? And now what happens to the symbols of the sides? Hey guys, enough please. So y equals 2x squared minus 16x plus 35. Is that correct? You got to check my math as we're doing this, right? I'm doing this pretty quick. That's one of them. Let's do the next one. What is it going to be? Negative y equals negative 2x squared plus 8x minus 11. The signs change again. Y equals 2x squared minus 8x plus 11. Yeah. So, type it into your calc. Now, if any of you really like this aspect of math, like you might really enjoy this with the technology, you might be interested in, you should take grade 12 pre-calc, but you might also think about taking grade 11 applied. This is a lot of applied. Applied math, you use a lot of technology. Whether you're using the TI-83, you're using graphing programs, you're doing stuff like that. If you like that technology aspect of it, you might be interested in this. Okay? Let's put these in the calculator. So I got to go back here. I go to y equals. I got to clear these out. Delete. Oh, actually, here, just hit clear here. What's the first one? 2x squared minus. Now, careful here. When I want to show you something, when you're doing this with the calculator, that's minus 16x, right? Do not put. You see how it's the big one up there? Do not put that as this one here. If you notice, that's a small one, right? That's the negative, right? Careful on that one. Don't make that mistake. It'll do. You have to do that if it was negative 2x squared, then you got to put the negative is in that one, the little guy. Right, so for instance, if I put it back here in front of the 2, yeah, we have the negative.
No, but if you put the negative and then multiply with it.
I don't want, I forget. Yeah, it multiplies. I think that's what it does. It does wacky things. But, I mean, it's a piece of technology, and these calculators have actually been around for a while, so. If you take grade 12 pre-cal with Mr. McLaughlin, you'll actually get to use some of the new TI Inspires. They're the color graphing calculators. They're like little computers. They do a lot more. You can actually, some of the new technology, you can actually put in a quadratic formula and press a button and it'll solve it for you. No. But he just shows it to you so you can use it. You see, some of you, this will be an advantage, like on a test, because you can actually find what the answer is and then do the algebra to check to see whether or not you did it correctly. Yeah, you just make the graph manually. You make a table of values. You know how to plot a quadratic. We did that. You know how to plot a linear equation. You don't even need a table of values. You know how to put these two on a graph, right? If you're ever unsure, you just do it with a table of values, like I said, but you don't need to. Yes. Well, hang on a sec. Did you forget a square? Did you forget a variable? Okay, let's find out. So let's set the window to, what should we set our window to? I'm unsure. What should I always send it to? Standard. 10. Okay, so here it is. There's one. Guys, where is all this information? In which quadrants? Do you have that on your? Okay, then you have it wrong. Okay. just hang on. I'll help you in a sec. Which quadrant is this all in? 1. Okay, so I'm going to set my windows. I'm going to get rid of some of these negatives. So I'm going to put -1, right, because I don't need all of that. No, because I often, if you put 0, what it does is it pushes the axis right to the edge of the screen. I always like it kind of at -1 so you can see the axis. It shifts it over a bit. It's something I've gotten used to doing. Wide man, let's try -1. Let's see what this looks like. Graph. That's not bad. What do you think of that? Does that work? Okay. Well, they're right there on the screen. See right here, this one here, the y equals this equation here. Oops.
Wrong.
Just, could you hang on 1 sec? Give me your calculator. Hey, give me your calculator.
I'm just saying. It's the exact same as yours.
You just said it was wrong.
No, they said it was wrong.
Oh, okay.
I said it was right.
Hey, don't bow to peer pressure. Don't listen to them. Okay. Okay, now, do we have an intersection? Wait, how many solutions? Can you see it's one right away? So there's one solution. How do we find it? No. Oh, well, we'll get to the guessing, but how do we find it? Second calc. There we go. What are we looking for? Intersection point. Bang. First curve, I'm just going to move over so I'm near it. There's one. I want enter. Is it on the other one now? Yeah, I'm just making sure it's on the other one. And what's our guess? What do you think our guess is? 1, 3. No, there's no zeros. It's way up in the air. 3, 6, 3, 5, 3, 4. Oh, let's find out. What do we get? 3, 5. So our intersection point is 3, 5. That's our solution, right? Well, because you have all this because you might want to graph it out, which is, I think, what I gave them. Well, what you would normally do is we substitute it back in, right? If you wanted to really check, you substitute it back into one of the original formulas and see if left side equals right side. That way you're guaranteed to show that you got it right? But I mean, the only mistake you would make in this one is if you put it, when you rearrange the formulas, the quadratics, if you put them in the wrong form, right? If you put these in the wrong form, like let's say you added -2x squared there instead of y equals 2x squared, it's really going to make a difference, right? These are both positive, they both... Well, I'll help you in a second. Alright, so 8.1. If it's a basic graphing question, they actually tell you to physically graph it out, grab some graph paper and do it. Try it, because you have to at least see what it looks like to do it manually. Then you can go back to doing it, how? Algebraically. That is the key there. That is what the pre-cal is all about. Okay? You got it? Alright, let's get working on these now.